Trig ratios. So a circle with center 0, 0 and a radius r with a point xy is shown. Point xy is on the terminal arm of the standard position angle theta. A vertical line segment connects the point xy to the x-axis. Label the resulting triangle with x, y, and r. Okay, what goes down here? Are you kidding? What goes down here? X. What's along here? And this r. The trig ratios of theta, sine, cosine, and tangent, can be stated in terms of the right triangle. State each of the following ratios in terms of x, y, and r. Okay, so sine theta is y over opposite over hypotenuse, which is y over r. Now this holds even when we move into quadrants 2, 3, and 4, right, where you no longer have an angle theta being an angle inside of a triangle, right? Theta is now will be a rotation angle into quadrant 2, but it will have a reference angle. That'll come in. Cos theta is x over r, and tan theta is y over x. These trig ratios are called the primary trig ratios. Okay, so they're the three biggies. The reciprocals of the ratios above are also important, and they're given their own names. The reciprocals of sine, cosine, and tangent are called cosecant, abbreviated CSC, secant, abbreviated SEC, and cotangent, abbreviated COT. Now, the way to remember how they pair up, well, tan and cotan obviously go together. There's only one co in each pair. So if you're thinking sine, is that secant or cosecant? There's only one co, so sine goes with cosecant, and cosine goes with secant. Okay, so just don't pair up two co's and you're fine. And don't try and stick sine with cotangent. That makes absolutely no sense. State each of the following ratios. So in terms of x, y, and r, if cosecant is 1 over sine, then in terms of x, y, and r, what do we get? R over cosecant pairs with sine. It's the reciprocal of sine. R over y. Secant pairs with cosine. R over x, and cotangent x over y. Okay, so really all you need to know is that sine is y over r and cos is x over r. The reciprocals, just flip them over. Okay, so if I say secant, you say secant is paired up with cosine. So it's reciprocal of cosine. If xy lies on the terminal arm, blah, 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 so this just puts it all together. So sine theta is y over r. Cos theta is x over r. Tan theta is y over x. And the reciprocals are just that. Just turn them over. Okay, so this you need to know, right? You're going to start looking at your formula sheet now and look at trig, right, which is like half your formula sheet. Let's see, do they list this stuff? You know, if they don't list this stuff, do they list this at all? Say sine theta is y over r or anything?
Yeah,
It's on there? Yeah?
yeah, it's on.
Okay, so then you don't have to memorize that particular thing. Or, really? Sine theta is... Doesn't say sine theta is y over r. So you do need to know that sine theta is y over r, cos theta, etc., right? It's not on your formula sheet. Okay. The point. I didn't skip anything. This is the next thing. The point, negative 2, 5, lies on the terminal arm of a standard position angle theta. State the exact values of the primary and reciprocal trig ratios. So if you like, you draw it a little, so that's negative 2. Here's 5, so we got this. There's the point, negative 2, 5. There's the angle theta. State the exact values of the primary and reciprocal trig ratios. So you have to identify x, y, and r. So x and y, they're just out of the point, right? So x equals negative 2. Y is equal to 5. So you don't need to draw a diagram. I'm just doing that to say, here's what it looks like, right? This angle is an angle greater than pi over 2, or greater than 90 degrees. We'll be flipping back and forth degrees and radians today. So just have your calculator ready and go mode. Okay, so we do a lot of calculator work, and we'll be flipping back and forth from degrees to radians all period. What's R? What's R? What's R squared? I can draw it in for you. There's X, there's Y, there's R. That's a 90. R squared is?
29.
X squared plus Y squared.
29.
So R is the square root of X squared plus Y squared, which is, yeah, so it's the root negative 2 quantity squared. So no matter what X and Y are, when they're squared, they're going to become positive. Okay? So if you're working out R, and you know that R is the longest side, it has to be larger than either of the other sides, right? So you can't have any negatives sitting under here. Plus 5 squared. So R is equal to the square root of 29. Okay, we got X, we got Y, we got R. We can list all of the trig ratios. So the primary trig ratio, so sine theta. Sine theta is Y over R, so that will be 5 over root 29, which could also be written as 5 root 29 over 29. Okay, either way, so you've got to be able to rationalize the denominator. That's really, it looks like root 2 times 9. Make sure it's, who knows? If it's multiple choice, look at the form of the answer. There are times when you're going to want to leave the radical on the bottom just for strategic purposes, right? Okay, when I'm going to solve this, and if I have, I know the other one's going to be radical up top, and then I can cancel. And there are times when you do this. If we ask you to the nearest hundredth, you just work it out. Okay? So there's no hard and fast you must. Generally speaking, I would say we do want rationalized denominators, but you know, cos theta is x over r, so that's negative 2 over root 29, or negative 2 root 29 over 29. And tan theta, what's tan theta? Okay, so y over x, so it's going to be 5 over negative 2. Okay, and we just write that as negative 5 halves. Okay, here's an interesting thing, right? Like, where does the negative go? Does it go with the x? Does it go with the y? So we know it goes with the x. If I write it as negative 5 halves, I just told you that tan is negative 5 halves. You say, well, either the x or the y could be negative. And we'll look at that in a few moments. Yeah?
Shouldn't it be like theta? Should it be the reference angle? Like theta r?
No?
Theta is
No.
the big angle?
No?
Theta r is the big angle.
No? No? Say no as many times as you like. No, tan theta, the definition of tan theta is y over x. Take the y, take the x. That's your answer. Okay. It has to be negative. Do you remember the cast rule from 20, right? So the tangent in quadrant 2 must be negative, right? Because it's a y value, which is positive, over an x value, which is negative. It has to be negative. We're going to look at that. We will refresh your memory of these things. So, what pairs up with sine? What's the reciprocal of sine? Cosecant. So what's cosecant theta? Root 29 over 5, right? Just turn this over. So you really want to look at this form, right? The first one you wrote, not this. You flip this over, then you got to re-rationalize and cancel. Okay, so we don't want to do that. Paired up with tangent is secant, so that'll be negative root 29 over 2. And paired up with tangent is cotangent, and that will be negative 2/5. Okay, now you always have to do the sine, cos, and tan of something. So I might just say the sine is this, right? But I really mean the sine of theta or the sine of x, the sine of some angle. Okay, it's the sine, the cosine, the tangent of something. Okay, you can't just write sine equals. That doesn't make sense. The sine of something. So if the sine of theta is negative 2/3, and theta is a quadrant 4 angle, so when it's written like this, then we know that sine theta is y over r. So what's y equal to? So like, could we say, okay, so y is 2 and r is negative 3? So what is it about r?
R is just the radius.
R is the radius of a circle, so it has to be what? It's got to be positive. So r is always positive. So if you see a ratio, so that's why with tan we don't know. It's x and y, so one could be negative, one could be positive. But with sine, it's y over r. R is the radius of a circle. It must be a positive quantity. So that means y is negative 2. So now we got to work out x. So what's x? Okay, well, you can start with this. R squared is x squared plus y squared if you want. Or you can just go to x squared is r squared minus y squared. Right, so if I'm working out x or y, it's r squared minus the other thing squared. So x is equal to plus or minus the root. See, the x value can be positive, but can also be negative, right? So plus or minus, so we've got 3 squared minus negative 2 quantity squared. So make sure if you're squaring a negative, you put it in brackets. Okay, this is 9 minus 4, so x is equal to plus or minus root 5. But there's a piece of information there that narrows it down, which is what?
Yeah.
So theta is in quadrant 4. What are the x values in quadrant 4? So here's quadrant 4. So the x value is positive. Okay, so you can say, but theta is in Q4, so x is equal to positive root 5. Okay, and we need that information. Right? If I tell you sine theta is negative 2/3, again, if you think back to the Cast rule, that in quadrant 3 and quadrant 4, the sine ratio is negative. We're going to go through that again. But so if you don't tell me which one I'm in, I'm either in quadrant 3, where x would be negative root 5, or I'm in quadrant 4, where x is positive root 5. Now here, that tells you where you're at. So now we can go fill this in. X is positive root 5, and determine the exact values of the 5 others. So we were given sine, so we need cos theta. So cos theta, cos is x over r, right? So it's root 5 over 3. Tan theta is y over x, so it's negative 2 over root 5. Or negative 2 root 5 over 5. What's left? So we got the 3 primaries now, so we need cosecant. What's cosecant? Reciprocal of sine. Remember, 1 co in each pair. So what's the reciprocal of negative 2/3? Negative 3/2. Secant theta. So at this point, we just look at this. So I'm going to go, it's 3 over root 5. So that's 3 over root 5, or 3 root 5 over 5. And cotan theta, so I get to flip either one of these guys. I'll pick the one that's got the radical in the denominator, because that will end up in the numerator. So it's negative root 5 over 2. Okay, so given x, y, and r, and how are you given those? They're given 2 out of the 3, really. Here, the point x, y lies on the terminal arm. So you're given x and y, you work out r. Here, we gave you the value of one of the trig ratios. Sine theta is negative 2 over 3. Okay, what's sine theta? Sine theta is y over r. R is always positive, so r is 3 and y is negative 2. Okay, then we can work out x. So the top one, given x and y, we had to work out r. Given y and r, we work out x. Once you've got x, y, and r, sine theta, you have to know, right? Sine theta is y over r. And if you want to know those, you can just go back to the original, sort of first principles, wherever the heck the first, but right here, right? And say, here's theta, sine is opposite over hypotenuse, so sine is y over r. And then move forward. Okay, is this the next one, or did I miss something at the bottom of the last page? This good? Are we on 6? Okay. Use the calculator to determine 2 4 decimal places. Okay, so we need to get out the calculator. So in degree mode, cosecant is 1 over sine. Okay, what's secant? Reciprocal of cos. So it's 1 over the cos of 5 pi over 6. Okay, now we got to be in what mode? So you got to go to radian mode. Okay, and I want 1 divided by cos 5 pi divided by 6. And that is negative 1.1547. Cotan, what do we do for cotan? 1 over 10, negative 2 pi over 3. Okay, so 1 divided by tan, negative 2 pi divided, and always use the pi key. 0.5774. Okay, any questions? So that's how we work out the reciprocal trig ratios, right? Primary trig ratios, it is what it is. Just make sure that you're in the correct units. Well, make sure your calculator is anyways. The point 4,3 lies on the terminal arm of a standard position, I guess angle, theta. Determine theta if theta is between 0 and pi over 2. So what units? Radians. Okay, so how are we going to do this? What do we know? We know an x and a y, right? Okay, so what's x? X equals 4. What's y? Y equals 3. Can we work out theta if we know that x is 4 and y is 3? Is there a ratio that uses x and y? Tan. So we could say the tan of theta, tan theta is equal to y over x, right? We're just going to write the formula down. Okay, I want theta, so how do I get theta? How do you untan? Stay out of the sun. You do the tan inverse, right? So you say, give me the angle whose ratio is 4 over 3. Okay, what units do we have to be in? Got to be in radians. We're in radians. Okay, good. So second tan inverse. Give me the angle whose ratio is 4 divided by 3. And that angle is 0.9273. Did it say 4 decimals or anything? X is 4, what? Oh, here. You mean like 3 over 4? Oh, totally different answer. Okay, X is 4, Y is 3. Okay, tan. All right, so what do we want? We want to flip that. So tan inverse of Y, which is 3, so 3 divided by 4. Which is 0.6435, 0.6435. Doesn't give things 6435. What are my units for theta? Radians. Rad. Okay. So this tells you radian mode. This tells you degree mode. Now, first of all, wait a sec. Is 0.6435 between 0 and pi over 2? Well, pi over 2 is 1.57, right? So is 0.6435 between 0 and 1.57? Yeah, okay, so we're okay. It's a quadrant 1 angle. Okay? And it should be anyways, because the 0.43 is in quadrant 1, right? So for degrees, what do we do? Well, we do the same thing, right? Tan inverse, so we say theta is the inverse tan of 3 over 4. So I just go back here. I just take the mode and go to degrees, right? I mean, you could convert that, but why would you? Why would you? Yeah, like don't. And then just go second enter, right? Just say redo this calculation, and it's 36.8699. I don't know, 36.87, 36.9. So depending on rounding, it's anywhere from 37 degrees to 36.9 to 36.87 to 36.870. We would tell you. So I'm going to go with 36.87 degrees. Okay, so the key is wrong on this question. If you're looking at the key, this is right and it's wrong. I don't know if I was copying the key and that's why I put the 4/3. Complete the table below. Oh, here, let's be lazy. Want to be lazy?
Yeah.
Okay, use trig ratio, round the values to the nearest thousand. Okay, so we're in degrees, obviously, right? Okay, follow along. It's only going to happen once. Mode, degrees. Okay, it's in degrees, cool. We're going to do this. Second mem. Number 4, clear all lists. Okay, I'm going to clear all the lists. I'm going to go into stat, edit, and in L1, I'm going to put in the angles I want, right? I want 30 degrees. Where was stat? Have you guys never done a regression? Come on.
What's a regression?
What's a regression?
Okay, so second.
Oh my God, okay. Let me start over. Okay. Second plus sign. Number 4, clear all lists. Hit enter, it says done. Okay, before you do any regressions, we don't do a ton of them in 30-1, but I just want to clear that. Okay, stat. Got it? Stat. Edit. We're going to go put numbers in. Okay, in L1, I want to put 30, 150, 210, and so 30, 150. I'm still rounded to 4 decimals, so I mean, and it'll show what it can. 210 and 330. Now they said nearest thousandth, right? So let's go to mode. What's thousandth? 3. So let's go to mode and we'll go to 3. Okay, go back to stat, edit. Okay, everybody got this? Yep. Okay, here's where the magic happens. Go over to L2 and go up top. Okay, and now you say the sine, and you go second function 1. Give me the sine of L1. Okay, you can close the parenthesis if you like closure, you don't have to. And hit enter. Okay, there's the sine of L1. So there's the sine of 30, there's the sine of 150, there's the sine of 210. Okay? So 0.500, 0.500, negative 0.500, negative 0.500. L1, second function 1 is where your L1 is. It's in blue. Okay, go back up top, press cosine, second function 1, L1. Okay, I could do it in L3 and L4, but it doesn't matter. I mean, I don't need to keep them. Okay, there are the cosines. Rounded to 3 decimals. Here's the full cosine. So 0.866. Negative 0.866. And if you're not doing that, then just use your calculator. Go sine 30, write it down, sine 150. Okay. Here, negative 0.866. So you're just copying this out of your calculator. And 0.866. Okay. Now, go up here and do what? Go tan, second function L1. Hit enter. Okay, 0.577, negative 0.577, so 0.577, negative 0.577, positive 0.577, negative 0.577. Okay, so that's the lazy person's way of doing this. I don't have to go sine 30, write it down, sine 150, and so on. Okay? What do you notice about the ratios in each column? So these are the same number, but they might have different signs. So what are we going to say? We're going to say their absolute value is the same. So just say the absolute value of the ratio in a column is the same. In other words, the size or the magnitude of the number, right? How big the number is, 0.5. That's all the same in a column. What do the angles have in common? 30, 150, 210, 330. It's got to do with, you should reference something.
Multiples of 30.
And multiples of 30, but what would you like to reference? Their reference angles are all the same. So each of these angles has a reference angle of 30 degrees. Okay, so all the angles have a reference angle of 30 degrees. All the angles have, let's say, the same reference angle. The same reference angle, which is 30 degrees in this case, right? Make sure you put degrees in degrees. Okay? So what does all that lead to? Complete the table by stating where the trig ratio is positive. So do you remember the cast rule? Okay, this is the cast rule. Yeah.
Does that mean that all
We'll fill in the table and then let's see what happens. Okay, so you've got it, right? You just look back at the previous table and you're just saying, okay, positive, positive, negative, negative, right? Complete the table stating where there's trig ratio. So positive, positive, negative, negative, positive, negative, negative, positive, and positive, negative, positive, negative, right? That just, all we did was take what we had in the other table and strip off the number and just say, in this quadrant, this ratio has this sign, which is a bad word to use because then there's the sign. So we could use polarity to indicate positive or negative. Others have. I probably won't. I'll just say the sign of the sign. Write each of the following in terms of the reference angle of the given angle. So, sine of 230, okay, so wait, just back up one sec. You know the cast rule? So the cast rule, which actually goes better as all science teachers combust, but you can't say asterisk rule, right? But just however you remember it. I learned it as the cast rule, but add sugar to coffee. You know, whatever you like. Make up your own, only different letters, A, S, T, C. So all trig ratios are positive, right? And if you think about it, R is always positive. In this quadrant, the x's are positive, the y's are positive, the x's are negative, the y's are, so x and y are both positive. Over here, the x's are negative. Where is there an x? Cosine and tangent. Over here, they're both negative. So sine and cosine will be negative because they have the r, so they have one positive. But tangent has both x and y, it'll be positive. And over here, the y values are negative, so the tangent's negative because you have positive x, negative y, and the sine is negative because you got a positive r, negative y. Okay, so cast rule. So here's how we do, right? The secret to trig, at least this part of it, it's reference angles and the cast rule. So, sine of 230 degrees. So where is 230 degrees? In which quadrant? Okay, so it's a quadrant 3 angle. What do we know about the sine in quadrant 3? It's negative. What is the reference angle for 230 degrees? 50 degrees. So the sine of 230 degrees is equal to what? Negative sine 50 degrees. Okay? So what we want to do is reference the reference angle, right? So when we write each of these, it's in terms of the reference angle. Okay, 5 pi over 6. Which quadrant is 5 pi over 6? Quadrant 2. What is the reference angle for 5 pi over 6? What's the reference angle for 5 pi over 6? That's the answer. What's the reference angle for 5 pi over 6?
1 pi over 6?
1 pi over 6, right? Because you just think, okay, like 5 pi over 6. This is pi, but pi is 6 pi over 6, so I need to go one more 6. Okay, so it's cos pi over 6. But in quadrant 2, the cosine is negative, so we get negative cos pi over 6. You were just there way ahead of us. 195. What quadrant? Quadrant 3. What's the reference angle for 195? 15 degrees. What's the tangent in quadrant 3? So we don't need to put it in here, right? It's the same as the tan of 15 degrees. Exactly the same, because they're both positive. 2. Which quadrant is 2 in? 2 is in 2. Okay. Quadrant 1 goes from 0 to pi over 2. Pi over 2 is a half of 3.14, is less than 2. Goes up to pi, right? Quadrant 2 goes from pi over 2 to pi, which is 1.57 to 3.14, so 2 fits in there. Okay? It's cosecant. So you got to do the reciprocal of cosecant, which is what? Okay. So let's just start off with okay, cosecant's reciprocal of what?
1 over sine.
It's reciprocal of sine. In quadrant 2, the sine is the sine of the sine?
Positive.
It's positive. The reference angle for an angle of 2 radians is pi take away 2. So there's my reference angle. It's still a cosecant. We're not going to change it to a sine. Right? I mean, we could at a later date if you wanted to. This is positive in quadrant 2, so it's just equal to this. Okay? So equals. Okay? If you had to work that out, then you would go 1 over the sine of pi over 2, right? So you're just saying cosecant. Cosecant has the same sign as sine. It's in quadrant 2. The sine is positive, so then the cosecant is positive, and it'll be the cosecant of the reference angle, which is, so if you want to think about it, that's 2. That's pi minus 2, right? So that's pi. That's pi minus 2. That's your reference angle. So that's pi, and that's pi minus 2.
Entire circle is 2 pi, so it's about 6.
Entire circle is 2, yeah, so circle 0, pi over 2, 1.57. Pi, 3.14. 3 pi over 2, something bigger than 3.14 and smaller than 2 pi, which is 6.28. Okay, so that's going to be 3.1 plus 1.6, like about 4 point, right? I mean, you could work it out on a calculator if you had to. If it was that close, right? Like 2 isn't close, so we know where it is. The point -8,5 lies on the terminal arm of a standard position angle, theta. Determine theta rounded to the nearest hundredth of a radian or the nearest degree if theta is between 0 and 2 pi. Okay, so the deal is -8,5, just, it lies. Where does it lie? Which quadrant is it in? So, -8. Okay, so this is a quadrant 2 angle. All right, so we want to work out, what do we want to work out? We want to work out the angle theta. What do we know? Well, x is -8 and y is 5. So if there were only a ratio that related x and y, but there is, which is it? Tangent. So tan theta. So start with this, right? Start with tan theta is y over x. It's just a basic fact, right? Then you could say theta is the inverse tan of, and now we can plug in our y, so 5 over -8, or you could just enter -5/8, doesn't really matter. And what's going to happen? So we want radians, right? Okay, so I'm going to quit out of this. Did it say nearest hundredth? I'm just going to go back to float. I can round on the fly. So mode, float, float. And we got to be in radians too, right? Radians. Second quit. Okay, so I go inverse tan of 5 divided by -8. And it goes and gives me a negative angle. But wait a sec. We are told that theta must be between 0 and 2 pi. So what's going on? Why is it giving me a negative angle? So it's basically saying, here's your angle here, right? Theta is negative 0.55. So here's how your calculator works. When you say, give me the angle whose sine, cos, tan, whatever is blah, it says, I'm going to give you the closest angle I can, measuring from the positive x-axis. So it says, if it's a positive ratio, I'll give you quadrant 1, and if it's a negative ratio, I'm going to give you quadrant 4. Okay? So what we've worked out is the reference angle. What we need to work out is we need to work out the reference angle here, right? So we need to say, okay, what's theta r? So theta r, remember, that's positive, right? Theta r is going to be 8 over 5, it's a value, x value of y, x value of 8 and a y value of 5. So we just can't work out the tangent of theta, right? So we have to say, what's the reference angle? So we'd say theta r, or the tan of theta r. So theta r is the inverse tan of 8 over 5. Reference angles are always positive. That's going to give us this angle, and then to find the rotation angle, we're going to have to work this out, right? Because we're going to get the reference angle. So we do the inverse tan of 8 over 5, which amazingly is going to be the positive value of this. Okay, second, clear. Okay, second, okay, touch. I don't want to insert text. Oh, I already did the tan inverse. Okay, so we want, y, 5 over 8. 5 over 8. Okay, so we want 5 divided by 8. In other words, we always just want to put in the positive value, pretend this is a quadrant 1 angle, and get the reference angle. So that's 0. What do you say? Nearest hundredth of a radian. So 0.56 radians. So the reference angle is 0.56. That's here. The angle is what? Pi minus the reference angle. Okay, so it's pi minus. So I'm just in the calculator, I'm just going to go second function pi minus second answer. Just bring that number down, right? Don't type in 0.56, just do that. And then round 2.58. So here's the deal. If you want to do an inverse sine, inverse cos, inverse tan, you need to do it on positive values. You need to work out the reference angle, and then work out the angle of the quadrant in which you're really in. So let's do the same thing here. So in degrees. So again, this is theta r. So the theta r, the reference angle, is the inverse tan of 5 over 8. Okay, so don't do that. Mode. Degrees. Quit. Okay, out. I'm just going to go second enter twice. Cut it out. Okay, so the tan inverse of 5 is 32 degrees. Now what are we going to do? We're going to go 180 minus 32, right, which is 148. So we figured out this, right? Theta r is 32 degrees, and theta is 180 degrees minus 32 degrees, or 148 degrees. So if you are working with a non-positive ratio, which would be a negative ratio, if you're working with a negative ratio, turn it into positive, get the reference angle, and then put the reference angle in the correct place. In this case, we need the reference angle, and then we're going to stick it in quadrant 2. Okay? If sine theta is negative, so if sine theta is negative, which quadrant could it be in? Could be quadrant 3 or 4. The reference angle for theta is the inverse sine of what number? So if you're given a negative ratio, right, and the ratio we had before was like 5/8. This ratio is already worked out, 0.5431. So if you are given a negative angle, sine theta, sorry, if you're given a negative ratio, sine theta is negative, then you say, all right, it could be quadrant 3 or it could be quadrant 4. Its reference angle is, and we need degrees, so we got to flip modes again. Oh, it's in degrees. Okay, so I'm just going to go sine inverse of positive, because if I do negative, it's going to give me a negative angle. It'll take me into quadrant 4, which actually could sort of be useful, except it'll be a negative angle, and so we don't want to deal with that. So we go 0.5431, and we get 32.89. So what do they want? Round it to the nearest degree. So call it 32.9 degrees. Determine all the values of theta, rounded to the nearest degree. All right, let's call this 33 degrees. Okay, so let's figure out, what have we got? I have a quadrant 3 angle whose reference angle is 33 degrees. And I have a quadrant 4 angle whose reference angle is 33 degrees. So theta is what? 5341. 5341. What's the answer? I don't know. That's not a good answer. I'm going to point out your error, but I will not correct it. 32 degrees. Fine. 32. 32. 32. Okay, so what's theta? 180 plus 32 degrees, which is 212. Or it's 360 degrees minus 32 degrees, which is 328. What is that? 328. Okay, so anytime you're working on angles, you got to think of two things. So number one, always work out the reference angle. If it's a quadrant 1 angle, then it just is what it is. But work out the reference angle, so always do the inverse sine, cos, or tan of a positive quantity. So you're always getting the quadrant 1 angle, which is going to be your reference angle, and then take that angle and put it into the quadrants that you require. So in this case, it could be quadrant 3 or quadrant 4, 212 and 328. It's all right? Solve for theta, rounded to the nearest hundredth of a radian or the nearest degree, given the indicated restrictions. Okay, so in this case, tan theta, theta is between 0 and 2 pi. So, tan theta is negative. Which quadrant? So you say, well, we're in quadrant 2 or quadrant 4. So I need a quadrant 2 angle, I need a quadrant 4 angle. I am going to work out the reference angle. So the reference angle, so theta r, is the inverse tan of what? Now you take just the positive value, right? So the reference angle is the inverse tan of 3 over 2. And we're in radians, so we got to convert to radians. Or calculator into radians. Mode, radian, quit, clear. Okay, so tan inverse of 3 divided by 2, which is, what do we want here is what, 100? So call it 0.98. So I need a rotation angle in quadrant 2 whose reference angle is 0.98. So if you want, draw a diagram. And label it. So there's a quadrant 2 reference angle of 0.98. My rotation angle is pi minus 0.98. And there's a rotation angle, or sorry, reference angle in quadrant 4 of 0.98. So what's my rotation angle? 2 pi minus 0.98. Okay, and then we just go work those out. So I can just go pi minus, and I'm just going to go second answer, right? Bring that, oops, clear. So I'm going to go pi minus, I'm just going to arrow up and grab that number and pull it down and say 2 point, what do we say nearest 100?
Yes.
2.16. Okay, so theta is equal to 2.16 and theta is equal to, and I can do the same deal. Actually, I could probably pull this down and just go over here and toss in a 2 and hit enter. So 5.30. Okay, give the next one a try. Use the secant. We're in degrees, so make sure you go mode, put your calculator into degree mode. There's something else going on, which is that it's secant, so you're going to have to convert secant into its reciprocal ratio and figure out how you're going to do this. I just do that for it. If secant theta is 4, then cos theta is 1 over 4. Do the easy way. Okay? Cosine is positive, quadrant where? So quadrant 1 and quadrant 4. That's nice because then the reference angle is one of our angles, right? So theta r is the inverse cos of 1/4. I guess we're doing this together. Inverse cos of 1/4. So 75.5, say nearest degree or nearest degree. So 76 degrees. So then theta is 76 degrees and 360 minus 76, which would be 14 last 286 or something. I don't know. Work that out. That's probably wrong.
284.
284. I think it was wrong. Yeah, 290, 360. Okay. Now, you get where these are coming from. So it is a quadrant 1 angle, so theta reference is the angle we want. And then we also need this, so if it helps, draw it out. Say 76 degrees, and this will be 360 minus 76 degrees. That's your 284. So anytime you're doing it is, if you need to draw out a diagram and label it and show your reference angle and put it into the correct quadrants, then do what you need to do. Okay, cos theta is negative 2/7. Which quadrant? 2 or 3. And sine theta is greater than 0. Which quadrant? Quadrant 1 or 2. So which quadrant are we in? Where do both happen? Okay, so there's your clue, right? We are working out just a quadrant 2 angle. We need cosine to be negative. That happens in 2 and 3. We need sine to be positive. That happens in 1 and 2. So the only place they happen together is quadrant 2. So I'm going to figure out theta. So we're in radians again. So theta is going to say, sorry, theta r. The reference angle, what do I do to the negative 2/7? I just make it positive, right? So when you're working out a reference angle, it is always of a positive ratio. That will always get you into quadrant 1. Okay? So anytime you do an inverse sine, cos, or tan on a positive, the calculator says, I can work that out in quadrant 1. If you do it on a negative, it's going to kick you into quadrant 4. That's why we don't want to do that, right? If you start getting quadrant 4, you don't want that. Okay, so actually, I no longer need to work all these out. I can copy. So the reference angle is 1.28 radians, but what quadrant do I have to be in? Need to be in quadrant 2. So if it helps, draw it out. So theta is pi minus 1.28, which is 1.86 radians. Okay, you don't have to write the word radians. Okay, you do have to put the degree symbol if it's degrees. Okay, cosecant is positive. What's cosecant paired with? Or sorry, cosecant is the reciprocal of sine. And sine is positive where?
Q2.
Okay, so if you tell me that cosecant is positive, then I say, okay, you're in quadrant 1 or quadrant 2. And now the secant is less than 0. So where is cosine negative? Quadrant 2 and quadrant 3. So where are we looking? We are looking in quadrant 2. So we need a quadrant 2 angle. Doing the reference angle, this is positive. The reference angle is going to give us a quadrant 1 angle, right? Because any ratio that's positive will always give you quadrant 1. Then we have to take that reference angle, stick it in quadrant 2, and work it out. And we're in radians. Okay, so I want cosecant theta, so what does that mean? I can't do cosecant. So theta r is the inverse sine of what? 1 over. Okay, so we have to work out the inverse sine of the reciprocal, 1 over 3.9812. Okay, I'll fill in the blanks for you. So the reference angle is 0.25 radians, but we're in quadrant 2, so it's going to be pi minus 0.25. Okay, so theta, the angle we want, and pi minus 0.25 is 2.89. Rad. It's rad. Well, we're almost done. Not bad, not bad. We could probably get through this. Okay. Hey, last two, right? Then we're done. Okay, do this. I'm going to pause the thing. You can do that. Do it. Do it. Okay, so tan theta is positive, quadrant 1 and 3. Cos theta is negative 2 and 3. So we're looking for a quadrant 3 angle. Reference angle, this is always positive, regardless of what this is. We do the inverse tan on this. We get 81 degrees. We take a reference angle of 81 degrees in quadrant 3. We get a rotation angle of 261 degrees. Secant theta. So secant theta is 5/3. What's cos theta? 3/5. So you need to change because your calculator does not have an inverse secant key. It has inverse sine, inverse cos, inverse tan. So you have to change any of the reciprocal trig ratios into a primary trig ratio. Okay, and then you start with, okay, tan is positive here, and cos is positive, sorry, and tan is negative here and here. So we are looking for a Q4 angle.
Do we have to write in Roman?
Yes. Do not refer to the quadrants with, the regular numbers. Use Roman numerals.
What if I forget it?
If you forget it, you'll call IXII. Don't forget. Now, quadrants are referred to as Roman. I'm not. It's like fine. It's it's jarring to the nerves, but we'll understand what you mean. So regardless of what's here, this is always positive. In this case, it is positive.
You don't have to do like that.
Well, okay, so if this said determine, which means show your work, I think you need to convert secant to cosine. You need to say that it's positive here, and it's like you need to make an indication of how do I know it's quadrant 4. If you just write down it's Q4, I'm going to say, yeah, a little more details. Okay? So give a reason why it's quadrant 4, right? Explain. I know that this is positive here and this is positive here, and that only happens that the secant is positive and the tan is negative will only happen in quadrant 4. Work out your reference angle, so call this theta r. And theta r is 0.93 radians. Okay, and I'm in quadrant 4. That's 0.93. So the angle I want is 2 pi minus, which is 5.36 radians. All right, we're done.